Okay, in this video I'm going to integrate cosine squared x and sine squared x. Before I do that, I'd like to bring your attention to my website universityphysicstutorials.com. Here I have all my videos archived and listed, and I also have a few other bits and pieces which may be of interest to you. So integrating cos squared and sine squared x is actually quite straightforward. However, oftentimes people think it's more difficult than it is. They perform slightly more advanced integration techniques and they get bogged down unnecessarily. And simply all they need to do is perform a trigonometric substitution. We begin with two trigonometric identities which I'm not going to prove. Cos squared x plus sine squared x is equal to 1. Cos squared x minus sine squared x is equal to cos 2x. Note of course that we're utilizing the double angle, so we have cos 2x. If I add the two of these equations and rearrange, we get that cos squared x is 1/2 outside of 1 plus cos 2x. I'm going to call that equation number 1. Now you might see that written in a slightly different but of course equivalent manner. You might have cos x is plus or minus the square root, and we have 1 plus cos 2x here, and we divide by 2 like that. And of course this is equivalent. I don't think it's necessary to use the square roots. I think perhaps it confuses the issue. Now, in order for us to get the identity for sine squared, we need to look back up here. So we plug this equation in for cos squared x, and we rearrange. Of course, that is a straightforward process. And what we get as a result is that sine squared x is 1/2 outside of 1 minus cos 2x. I'm going to call that equation number 2. So now we have the double angle formulas for cosine squared and sine squared x. If you want, you can transform this to the half angles by substituting x over 2 instead of x, and you get the half angle formulas, which I'm going to call 3 and 4. Now we have all the machinery we require in order to integrate cos squared and sine squared x. The first one I'm going to integrate is cos squared x, and I'm going to integrate it along the limits of minus pi to pi. So I substitute equation 1 in for cos squared. We do that here. Thereafter I integrate 1 with respect to x, which is simply going to give us x, and I integrate cos 2x with respect to x. That's going to be sine 2x divided by the derivative of the argument 2x, which is going to be 2. So we get sine 2x over 2. Now, the limits can actually be quite tricky, and that's because we have the argument of the sign is minus. Remember, the sign of a negative number is minus the sign of the positive number. So just being careful with that and evaluating the limits, we see that the evaluation is pi. We call this equation number 5. Namely that the integral of cos squared x from minus pi to pi is pi. Okay, so a lot, I'd say, more straightforward than you would have expected. Of course, integrating sine squared is going to be equally as straightforward. We plug in equation number 2, half outside of 1 minus cos 2x, do the same integration. This time, of course, there is a minus sign here instead of a positive sign. Integrate the limits, or excuse me, evaluate the limits, and we find out that this is also equal to pi. So the integral of sine squared x on the region of minus pi to pi is pi. So that's pretty straightforward, and that's all I've got to say about that. So thanks for watching. Please pass it on to your friends. Subscribe to my YouTube channel, and you might also check out universityphysicstutorials.com. Thank you.